Hello students, today we will see about multiple access techniques in wireless communication. So what is multiple access techniques? So these mobile companies are increasing their revenue by increasing their number of users. So while increasing the number of users, the quality of service should not degrade. So the multiple access technique is nothing but how efficiently a mobile company allocating its resource to individual users. Okay, we will see the things one by one. Okay, so here the total available bandwidth in India, this spectrum allocation is organized by TROI. This TROI represents a Telephone Regulations Authority of India. It comes under Department of IT, in central government, Department of IT. So this TROI, this is responsible for allocating the spectrum to each and every wireless or cellular networks. So the dominant network operators in India are Jio, Vodafone Idea, as well as Airtel and BSNL. So what this network will do is they will first get license of a particular frequency band from the government, and they will allocate this spectrum bands to individual users. So this frequency allocation process is handled by this multiple access techniques. So the spectrum band available for communication is from 700 megahertz to 2400 megahertz. So this is the spectrum band which is available for cellular communication. So if you see, if you buy a new phone, it will be specified that that phone will support a particular band, NS2 band or something like that. So it tells about the which frequency band. Sometimes they may help 5G, sometimes they may help 4G. So this spectrum band, that is the actual resource available for communication. Now you may have a doubt why we are choosing this spectrum band for cellular communication. So you may use this Bluetooth, you may use this Wi-Fi with free of cost. But for this cellular communication band, we need to pay money. Okay. The thing here is, so you can use a Wi-Fi or a Bluetooth for 1 kilometer transmission. But when I want to transmit a smaller range frequency to higher range, I need to use more power. Whenever I need to use more power, that will create radiations. So for that constraint only, we are choosing this optimum spectrum band, that is minimal radiation and maximum coverage. So that is in between 700 megahertz to 2400 megahertz. So this is the actual resource for our government. So in India, we have taken this band for cellular communications. Now, what will happen is this band will be allocated to during the lease. Okay, for different auction will be there, and a particular cellular company, they will acquire a particular band and they will start their service. Okay, so this is the basic behind this multiple access techniques. So now we are going to see what are the different types of multiple access techniques and how the process in which they will allocate the frequency to individual users. So now, in multiple access techniques, the first one is FDMA, frequency division multiple access. Second one is TDMA, time division multiple access. The third one is CDMA, code division multiple access. So when you go through the different generations of cellular communication, this FDMA comes under 1G, this TDMA comes under 2G, and this CDMA comes under 3G. So these are the different generations. Now we will see one by one. The first one is FDMA, that is frequency division multiplexers. In FDMA, that means the frequency division multiplexers, the total available band. So, this total available band that is divided into non-overlapping subbands called channels. So, for example, as I told earlier, the spectrum available for communication is 700 to 2400 megahertz. This is the entire bandwidth available for communication. So, this bandwidth is divided into non-overlapping subbands called channels. So, channel 1, 2, 3 up to n. Okay. So, this non-overlapping subchannels are allocated to user only when there is a request from the user. When the user requests a base station, a particular channel, this subchannel will be allocated to the user. So, this is just an extension of your FM. So, the thing here is we are having a particular channel for a particular user. So, in FDMA we are using only analog, that's why it is called as first generation cellular communication. So, these channels are very narrow. So, the bandwidth of this will be something 30 kilohertz. So, this is the actual, here you can only transmit voice. So, the advantage here is very simple, and also here we will be following the static channel allocation. That means, so the channel allocation will be fixed, whether the user is idle or not, a particular channel will be allocated to a particular user. So, the advantage here is very simple. Here we don't need any synchronization. That means the user 1 has to be synchronized with user 2 or something like that. We don't need to think about the other users. So, that is the first one. The second one here is, so you need to talk about God band. Okay. So, what do you mean by God band? So, to avoid interference between adjacent channels, some part of the spectrum is left unused. So, these bands, that is said to be God bands, remember that these God bands are only used to avoid interference, and they will not be used for any type of data transmission. Okay. So, here this God band again becomes a disadvantage here. Since the resource is spectrum, we are using some portion of the resource to avoid the interference between adjacent channels. So, this is basically the entire overview about FDMA. The bandwidth is there, we are dividing into non-overlapping subbands called channels, and these channels will be allocated to user on demand when there is a request from the customer, and to avoid interference between adjacent channels we will be using this God bands. So, God bands are used only to avoid the interference, and it is not used for any type of data transmission. Again, it comes under 1G mobile communication, it comes under analog type of mobile communication, and the bandwidth used here is very narrow, something like 30 kilohertz. Okay. So, this is the basic multiple access techniques. So, this is how in first generation the mobile companies allocated their spectrum to individual users. Okay. Now, the second one is, so TDMA. So, TDMA stands for time division multiplexers. So, most of the GSM SIM cards, they will use this technique, time division multiplexers. So, here we can say this is as a digital one. Okay. So, here we can also send text, can send messages, and if you go for 2.5G, an extension of this TDMA, you can use this GPRS also. So, this is the advanced level. at this period only, the mobile communication got more attention among the customers, and many people start using the mobile phones or something like that. Okay, so now we will see the entire technique behind this. So see here, so the same here, frequency as well as time. So now what will happen here is the time. Here we are dividing the time slot into subslots, and each user is allocated a particular time slot. For example, something like you will be having the same lab, VLSA lab or optical lab or anything like that, but the same lab will be used by different sections, different departments at different time period. Same way here, the total available time is divided into time slots, and in a particular time slot, some example, at the particular slot 1, this user will use the entire bandwidth. Okay, so the entire bandwidth, but only during a particular time slot, the user can use the entire bandwidth. Now again, it will further divide into narrow band and wide band. Narrow band TDMA, second one is, so what is called as narrow band and wide band TDMA? Suppose if this geo network is using the spectrum between 700 to 750 megahertz in Tamil Nadu. Okay, so what will happen is, so if the customers are only 2G or the customers are only 3G or 4G, so the spectrum here is 50 megahertz. So how to calculate the bandwidth? IS bandwidth minus OS bandwidth, that is 750 minus 700, that will be around 50 megahertz. So what will happen here is, depending upon my requirement, I can use the entire band, that is entire 50 megahertz. If I use the entire 50 megahertz for all the users during a particular slot, that comes under wideband TDMA. But in this case, if my requirement needs only 10 megahertz, and this 10 megahertz is shared among the different users, that comes under this narrowband TDMA. Again, this also an application specific multiple access techniques. So here the number of users, the area where we deploy the infrastructure and other things decide whether we want to go with narrow band or wide band TDMA. You'll be having a doubt. How, if there is a, what to say, delay, or how I can use a different time slots, and how there will be the continuity in transmission of voice message. So for the answer for this question is, here it follows the sampling theorem. So what is sampling theorem? So the frequency will be twice the maximum frequency of the message signal. So here, when you follow the sampling theorem, if there is any discontinuities, you won't able to what to say, feel that. So the first thing, whenever when you use a sampling theorem, you need to say this comes under digital technique, digital modulation technique. So this TDMA is a digital technique, and when you follow this sampling theorem, sampling time interval, so that should be followed, so you can get a continuous voice transmission. Okay, another thing. So in FDMA, we used the God band to avoid interference between adjacent channels. So here, what is the exact word you need to use here is God time. So please keep in mind, this God times are used only to avoid the interference between adjacent slots, and during these slots there will not be any data transmission. So comparing to FDMA, there we use the bandwidth, that is the resource itself. We preserved some resource to avoid the interference between adjacent channels. Here slot time. So this time period is essential to avoid interference between user 1 and user 2. So a typical example for this is, so when you use a particular lab at different time or different dates, okay, so it should be known to all the people, else there will be a collision. Same way here, the synchronization is very much needed here. What do you mean by synchronization? Okay, so the different users using a particular slot, they should know what is the time slot allocated to a particular user. If not, then there will be collision. So in TDMA, synchronization is very, very important, as well as equalization. So to avoid the inter-symbol interference, we are going for this equalization. So filters has to be designed properly. At the same time, the particular slot time should be followed, else there will be collision or interference will happen. So to if n number of users in a particular base station, each user should know in what time slot they need to transmit. So that is the advantage as well as the disadvantage of this TDMA. So once again I will repeat, in TDMA that comes under second generation mobile communication, here we are using digital techniques, digital transmission techniques. So the total available time is divided into sub slots, and each user is allowed to transmit in a particular time slot, and that will goes on repeating. So here, to avoid the interference between adjacent slots, we will be using God time. So please do remember, this God times are only to avoid the interference and not to transmit any data. So depending upon the nature of the applications, here we can go as narrowband TDMA or wideband TDMA. So in case of narrowband TDMA, the entire bandwidth, for example 50 megahertz, will be used among the different users, else they will be divided into 10 megahertz, and that will be used among the different users. Okay, so here the main thing is we need synchronization. So what do you mean by synchronization? So if there are n users, each user should know in what time they need to transmit. So that is said to be synchronization. So as well as equalization is needed here to avoid the inter-symbol interference between different symbols. So the famous one is GSM, and in 2.5G we will be using this GPRS technique. That is the initial stage while internet enters into mobile communication. Okay. So the third one that is quite different, CDMA. So code division multiple access. So what do you mean by code division multiple access? We will see one by one. Okay. In FDMA, the particular user can use a particular frequency band, that is subchannel. In TDMA, the user can use the entire frequency band, but only during a particular time slot. So this CDMA is the user can use the entire bandwidth, entire duration of time, but they need to use a code. So this is said to be code division multiple access. This comes under 3G. Okay. So in the 3G mobile phones, they use this technique for communication. The user can use the entire bandwidth, entire time duration, but they need to follow a particular code. So I will explain this with an example. You may hear about this PN sequence. So what do you mean by PN sequence? Pseudo noise sequence. So what is pseudo noise? The name itself it is not exactly random, but a type of random. That's why it is called a pseudo noise, pseudo random or pseudo noise sequence. Okay. So depending upon the number of customers, the sequence will vary. Okay, starting from binary to anything. Okay, so the sequence will vary, and here we will be using a technique called spread spectrum modulation. So it is also called as DSSS. That means dynamic spread spectrum technique. Important 2-mark question. So in spread spectrum modulation, the data will be transmitted with higher bandwidth than the minimum needed bandwidth for its transmission. So that is said to be spread spectrum modulation. So I will explain how these codes will be assigned to different users and how this technique is used in the transmitter side as well as the receiver side. So take this example. Okay. So this is a base station. So the function of this base station is to allocate channels among different users. That is the basic function of base station. Okay. So for example, take user 1, user 2, user 3, user 4, user 5, user 6. So here there are 6 users connected to this base station, and all the odd users 1, 3, 5. For example, we will take them as a transmitter, and the even users 2, 4, 6, we will take them as a receiver. Okay. So in CDMA, what will happen here is this base station, the user can use the entire bandwidth. The user can use the entire bandwidth and the entire time duration, but they will share a common code. Okay. So in such cases, an example. So now I am relating this code with language. Okay. So I will take 3 languages: Tamil, Hindi, English. So here user 1 will use the entire bandwidth, entire duration, but user 1 and 2, they will communicate by using Tamil. Same way, user 3 and 4, they will communicate by using Hindi. User 5 and user 6, they will communicate by using English. Okay. Now listen. So now they will use the entire bandwidth, entire time duration. So this Tamil is a code word. Okay. They will speak in Tamil, they will speak in Hindi, they will speak in English. Now this for this user 1, user 2, they will also hear Hindi and English. That means the communication of user 3 and 4 as well as the communication of user 5 and 6. So now we will be having a doubt. So how will they avoid interference? So that is the specific idea behind the CDMA. So the people who are using this code word then also hear the other code words, but they will appear as noise. That's the main thing. So they don't know English, or they don't know, the people who are using Tamil don't know Hindi or English. So they may also listen, but they could not decode it. Okay, so those who are using Hindi, they will also receive Tamil and English, but they will not decode it. Same way, the people who are using English, they will also listen Tamil and Hindi, but they cannot decode this. Okay, so things here is now compare the language with a particular PN sequence. So let it be an example. So 0010, 0101, 1100. Okay. So this is said to be a PN sequence. So all this PN sequence allocation is done by this base station. Okay. When a user tries for uh, initiating a communication, this base station will be allocating a particular code to a particular pair of users. So now you may hear about this autocorrelation, cross correlation properties. So what is autocorrelation? Autocorrelation means comparing your mark. For example, if you are writing your cat 1, comparing your marks of cat 1 with cat 2 and cat 3. That is said to be autocorrelation. Same codes compared with different time instants. Cross correlation, comparing your mark with some other students. So what we want to say here is this autocorrelation should be as high as possible. That means if a person is using Tamil, that should be pure Tamil so that the person who uses English couldn't decode it. Okay. So at the same time, the person who is using Hindi, it should be autocorrelated or orthogonal with each others, and it should not able to decode the person who is using Tamil and English. Technically speaking, if all these codes are orthogonal to each other, only the particular users, okay, they can only decode this and the other users cannot decode this. So this is the basic idea behind this CDMA. Okay, in 5G NOMA, okay, non-orthogonal multiple access, they are also they will be using the same thing, but a slighter extension of this coding will be there. Okay, so this is 3G. Now we will see with an example how the PN sequence is allocated, how the spread spectrum communication comes into play, and how this will be used for communication. Okay. Okay. So this is an example. So this is the data. This is the PN sequence. So 101010 101010. So just simple XOR operations. If you go for the standard books, they will be using XOR operations. When you see some local books, they will be using XNOR operations. Whatever it may be, go with the standard books, use XOR operations. Okay. Now I will be using XOR operation. So this is said to be the PN. That is 1010. This is said to be the PN sequence. This is goes on repeating. Okay. This is goes on repeating. Okay. So here see XOR operation. So what is XOR operation? 0 0. So in XOR operation, if both the symbols are same, we'll be getting 0. If both the symbols are different, you will be getting 1. Okay. So, see. So, this is the data, this is a sequence, this is the modulated data. So, listen 1 1. So, 1 1 0. Now 0 1. Okay. 0 1 1. So, 1 1. Okay. So, 1 1 again 0 1 1. Okay. Again 0. Again 0 0 0 1 1 0 1 1. Again 0 1 0 1 0 1. So, this is the modulated data. So, what we learn from here is, as I told you, it comes under spectrum modulation. So, this is a low frequency data, will be a low frequency one, the PN sequence will be a high frequency one. After modulation, the low frequency signal will be converted into a high frequency signal. That comes under, the data is transmitted with much more bandwidth than the minimum needed bandwidth for its transmission. Now, this is at the transmitter side. Now, see at the receiver side. So, here this will be used here, that means 0 1 0 1 0 1 0 1. Okay. This is the received data, that is the receiver end. So, the important thing you want to note here is the same PN sequence. What we used here is we need to use there also the same sequence, that is 1 0 1 0 1 0 1 0 1 0 1 0. So, now the same XOR operations. Okay. So, when two symbols are same, you need to use 0. If two symbols are different, you need to use 1. So, now tell me. So, 0 1. So, 1 0 1 1 1 0 1 0 1 1. So, here 0 0 0 0 1 0 1 1 0 0 0 0. So, 1 0. So, this is the recovered data. So, just see this data as well as the recovered data. So, what we are doing here, we are taking a data and we are using a PN sequence here. So, we are using the modulation, the spectrum modulation. So, the data will be transmitted with the minimum needed bandwidth for transmission, and this modulated data will be transmitted and that will be received at the receiver end. In the transmitted end as well as the receiver end, we are using the same PN sequence for decoding. Okay. So, since we are using the same PN sequence, when you decode, you will be able to get the actual transmitted data. So, since I told you this comes under spectrum communication, the data will be transmitted with more bandwidth than the minimum bandwidth requirement for its transmission. Okay. So when the question has been asked, you need to write the definition diagram, and if you draw this transmitter end and receiver end diagram, that will be quite good. Okay. So what is the advantage of this CDMA? So as I told you, this CDMA comes under 3G, and you will be in a position to transmit with high speed. It will not, you need not to think about this time slots, you need not to think about the frequency band, you can use the entire bandwidth. But even though there are some problems in this CDMA, so there are the advantages in CDMA: higher bandwidth and fast data transmission, as well as reliable service you can get in CDMA. The main disadvantage we will see one by one. Okay. So near far problem. This is also an important 2-mark question, please note it down. So what is near far problem? So in CDMA, users who are close to the base stations, okay, as well as some users will be far away from the base stations. Since we are using the entire bandwidth as well as during the entire time period, so the users at, so they who are close to the base station, they may be having some power related issues. So that problem is said to be near far problem. Also hidden terminal problem. Okay. So what is hidden terminal problem? So some users may not be in a particular base station's coverage area, but it may be in some other base station coverage area, as well as it may not be in a particular transmitter's coverage area, particular user's coverage area, but may be in some other user coverage area. In such cases, there will be overlapping of areas, and you need to solve these problems also. And usually the CDMA, they will take more power since we are using the entire bandwidth. So where your battery is, if the cell phone is on, so you need to what to say, scan the entire bandwidth and the entire time duration. So it consumes more power. So the battery life of these type of phones, usually the initial stage, the Geo, not Geo, Reliance phones, that comes with non-removable batteries, and then they use these types of techniques. Okay. Now we will compare all these things and we will wind up the session. So once again I will tell you CDMA, code division multiplexers, it comes under 3G. User can use the entire bandwidth, entire duration of time, but they need to share a common code. Okay. So the PN sequence or chip sequence, this is a high frequency signal, the data will be a low frequency signal. So the data will be transmitted with more bandwidth than the minimum needed bandwidth for its transmission. So now we will see the comparison of the 3 multiplexers techniques. The simplest difference, if you compare all these things, is the first one. So this will comes under FDMA 1G, TDMA 2G, as well as this CDMA 3G. So these are the different evolutions of cellular communication. And the next one, okay. So here if you see the technique, so here frequency, the total allocated bandwidth is divided into subbands or channels. Okay. Frequency separation, here time, the total allocated bandwidth a user can use in a particular time slots. Here the user can use the entire bandwidth, entire time duration, but they need to use a particular code. So this is the techniques of the 3 different types of multiple access techniques. The third one will be so narrow band or wide band. So the FDMA, as I told you, since it is 1G, this will be narrow, and this will be, it can be both narrow and wide. The CDMA, it will be wideband communication. Okay. So now to avoid the interference between adjacent users, here we will be using the God band. So the purpose of this God band is to avoid interference between adjacent channels, and these bands will not be used for any type of data transmission. In TDMA, we will be using God time. Okay. In CDMA, we will be using, there is no special cases, but the orthogonality of the codes will be discussed here. The PM sequence, as I told you, Hindi, Tamil. So if you are listening to Hindi, you should not listen Telugu or something like that. So that is said to be orthogonality of codes that should be maintained for better communication. Okay. Next one is synchronization. So synchronization means a particular user should know about the usage of other users. That is, in a particular network area, a particular user should know about the usage of others users. So here synchronization is not required. But in TDMA, since we are handling with time, the synchronization is needed for a better communication. And in CDMA also, we don't need any type of synchronization. Next one is equalization. So here equalization is not needed. Here we need filters for a better transmitted. Here also we don't need filters for a better one. So apart from this, you can say this FDMA that belongs to analog type of communication, TDMA that belongs to digital type of communication, and CDMA that belongs to digital type of communications. Okay. So these are the three different multiple access, and these are their differences. In examination point of view, they may ask about each multiple access scheme. You need to draw the diagram, you need to explain their technique, and sometimes they may ask about the comparison of the different multiple access techniques. So you should keep in mind the different key points, and you should write all these things. Thank you. தலைவரே எவ்வளோ வந்திருக்கு தலைவரே?